हेलो एवरीवन, लेट्स सॉल्व टुडेस डेली चैलेंज। और आज का हमारा चैलेंज है सम ऑफ लेफ्ट लीव्स। तो इस क्वेश्चन में इट्स क्वाइट एन इजी क्वेश्चन। हमको सिर्फ रूट दिया है बाइनरी ट्री का एंड वी नीड टू रिटर्न दी सम ऑफ ऑल लेफ्ट लीव्स। ठीक है। एंड लीव ऑब्वियसली वी नो इज अ नोड विच हैज़ नो चिल्ड्रन। तो जितने भी नोड्स हैं ये दीज आर लीफ नोड्स, क्योंकि इनके और चिल्ड्रन नहीं है। एंड अ लेफ्ट लीफ इज अ लीफ दैट इज द लेफ्ट चाइल्ड ऑफ अनदर नोड। ठीक है। तो अगर यहाँ पे इफ आई ट्राई टू मार्क व्हाट आर द लेफ्ट लीव्स, राइट, सो यहाँ पे जाऊँगी इस नोड पे तो मैं देखूँगी इसका लेफ्ट नोड। ठीक है। अगर मैं देख पा रही हूँ ये एक लीफ नोड है, दिस इज़ अ लेफ्ट लीफ, राइट, क्योंकि इसके चिल्ड्रन है नहीं, तो ये लेफ्ट नोड भी है एंड इट इज़ ऑल्सो अ लीफ नोड। तो ये नोड है एक लेफ्ट लीफ, राइट। Similarly, if I go to this node, right, and if I see what is at the left and what is at the right, so first of all, both are the leaf nodes. दोनों ही क्या है, leaf है, right? But this is the left leaf because this is the left node as well as a leaf node. So I've marked this. Now I have to return the sum of all the left leaves. All right. So that's what the question is. So here what will be the answer? 9 plus 15, that is 24. Now let's come to how to solve this. Now obviously, again, as I said, it's an easy question. So what we have to do is, so what we're going to use is recursion, right? So we're going to take O(n) amount of time, that is we're going to go to each and every node, and standing at each and every node we are going to check what is the value on the left and the right. So on the left, when we will checking the node, we will check if its children left and right both, they are not present, that means this is a leaf node. And because I already know this is the left node of this particular node, I can include it inside of my answer. So what I'll say is, I'll take a global variable called sum, which will initially be 0. I'll add this node's value to sum, right? So node left of left, because this was the current node I was at and this was the left node of it. And um yeah, so sorry, this is not going to be left, this is going to be value. All right. Okay, so node of left of value, this is what we're going to add. So while checking that is it a leaf node or not, we have to check node of left left, right? It should like, if it is not null, it will return us true because it's null and not. So not null means true, right? So in case node is null, all right. Similarly, we'll check for the node of left of right. Okay. So yeah, so I hope now like it's understood हमें करना क्या है. So inside of the recursion, these are the only condition that we are going to add. Otherwise, whatever is the sum, we will return that. ठीक है. तो ये condition check कर ली कि भाई if जो ये condition है, node of left is not, that is if it is true. If not, node of left of right, correct? If it is also true, so and we have this value, at least this node should be present, right? If this is null, then how can we get an answer? So this should be present. So node of left we will check, and we will check not of this. So if all of these three conditions are true, we will add this, right? We will add the sum. Otherwise, we'll simply check if we are going on to the node left, if it exists, but if it's not null, then I have to go and traverse in that node and find out if it has a left and a right child, and of the left child, right, of the left child, if it is a leaf, I have to add it. Otherwise, I have to keep iterating to all the nodes and calculate the sum, right? So that is what we have to do. So here we'll check node of left, then we will say simply return whatever sum you get from this, right? Go to this node and return. So recursively call the function. Okay. Similarly, go towards the right, because see, it's not like just you have to go to the left. Here you can also get and stumble onto a right node whose child have a left leaf, right? So this particular node can have a left leaf, but of this node, this is the right child, so we don't have to ignore this. This is also a left leaf, right? So standing at a particular node, you have to check for the left leaves. So this is what we have to do in this question. Let us quickly see the code, then it will be much more clear. So here you have to write node of right and then return whatever the sum you get from after going onto this node. All right, and in the end you have to simply return the sum. So here, see, we are checking if root doesn't exist, then simply return the sum. And if this condition, right, if root of left exists and root of left and root of left of right, correct, and these are not, basically this means true, that both of these are null, right? So this is a left leaf, so we have to add it, right? So we have to add the root value here, root of left of value. Okay, it got cut here, but yeah, it's root of left of value. Then the next condition is if we have the left node, right, but it was not the left leaf, then go onto this node and check for the left leaves and return their sum. Similarly, if you go here, root of right, then if this node exists, go on to the right node and check if it has left leaves and return the sum accordingly. So we are recursively calling the same function, and in the end you can simply return the sum. So now I hope the question is clear.